Assalamualaikum warahmatullahi wabarakatuh, and hello to Doctor and everyone. Welcome to my video for SIF 1005 Electronics 1. My name is Delima Humaira, and in this assignment, I will be discussing about the bipolar junction transistors or BJT and how does the base current in BJT control the overall operation of the transistor. So let's get into it. To begin, what is a transistor? Well, a transistor is an electronic device that can be used as an amplifier or as an electronic switch. Its ability to amplify a signal or to switch high power loads using a small signal makes it essential in electronics. There are two types of transistors, the bipolar junction transistor, BJT, and the field effect transistor, FET. In this video, I will just focus on the BJT. So, BJT comes in two types, PNP and NPN, where both consist of three semiconductors regions that are doped differently. That is the base, collector, and emitter. The base is thin and lightly doped, the collector is moderately doped, while the emitter is heavily doped. For a BJT to operate as an amplifier, the base collector BC junction must be reverse biased and the base emitter BE junction must be forward biased. Please remember this. So let's look at NPN transistor. The forward bias base BE junction allows free electrons from the emitter to flow into the base. The base is lightly doped, only a small fraction of electrons recombines with holes in the base, creating a small base current called IB, while the majority of electrons are swept into the collector across the reverse bias BC junction, creating a larger collector current called IC. This relationship is expressed as IE equals to IB plus IC, and also IC equals to beta IB. Since IB is small, we can see that IC is approximately equal to IE. How about PNP transistor? Well, in a PNP transistor, the operation is similar but reversed, so the holes are now the majority carriers. If we compare the current direction of these two transistors, we'll see that the flow of the current in the PNP transistor is just opposite to the flow of currents in the NPN transistor. So why does base current matters? The small base current IB controls the larger collector current IC due to the transistor's current gain, that is the beta. Looking at this graph, we can see in the active region, the transistor amplifies signals with IC equals to beta IB, while in the saturation region, IB is large enough to turn the transistor fully on, acting as a closed switch. But in the cutoff region, IB is equals to 0, so the transistor is off, or acting as an open switch. After seeing all that, we can conclude that the base current in a BJT plays a vital role in the transistor's operation because it controls the larger collector current, enabling the transistor to act as an amplifier or as a switch. That is all from me. Thank you.